You've all gotten to the point in your educational careers where you know the steps of the scientific method. You've been studying it for years and years. We don't need to go over that. What we're going to focus mostly on is what are the parts of a good experiment? What makes good experimental design? You're going to be designing experiments and carrying them out and interpreting the data. So what goes into that, and what are the components of an experiment? We'll be talking in this little presentation about hamsters. And the first part is you need to develop a hypothesis when you're going to carry out an experiment. And developing a hypothesis is coming up with an answer to a question, stated as an if-then statement or an I believe because statement. It's an educated guess. That doesn't mean you have to go to school to make one. It means it's based on prior knowledge. If I do this, then this will happen, because this is what I've seen in the past. I prefer this bottom part, I believe, because it makes you really activate that prior knowledge. I believe that if I do this, then this will occur. It has to be a testable hypothesis, because let's say, for instance, if you're looking at what type of food is best for hamsters, and so you want to make a hypothesis about that. You know, I've got KT variety food, I've got Sunburst, and I've got Encore. Which one should I feed my hamster? You know, which one's going to make my hamster happiest? Yay! Well, that's not a good testable hypothesis, because you can't judge the happiness of a hamster. They don't wag their tail. They don't smile. So it has to be, I believe this will make my hamster most active or gain the most weight. So we could make a hypothesis that says, I believe that KT food will make my hamster the most active because in the past I've seen my hamster be the most active when I've given that kind of food. That's perfectly fine as background knowledge. Now, if I want to design a good controlled experiment to test out this hypothesis, I have to have a couple of things in place. First, I have to have one variable being tested, and only one. Not two, not three, only one thing, because then I'll be sure that that one thing is what caused the difference. Everything else has to be completely controlled and has to be the same. We'll talk about some different examples of that. It has to have many test subjects. I can't base my entire results off of just one test subject. There should be multiple test groups, not just two. For the most part, you can't have an experiment say, I want to see either this or that. There should be multiple groups to give you a range of an effect. And it has to be clearly measurable. You have to be able to actually record data, because the data that's collected from an experiment is really what gives the answers to a scientific problem. So let's say I have a hamster cage. What do I need to put in it? Well, a hamster. And I probably want to put in a wheel, so it has something to be active on. And if I'm testing hamster food, I have to have some sort of a food dish. So here I have a setup. I want to find out which one's going to be best. Well, I might only have one variable, and that would be the hamster food. So I might set up a bunch of cages, each having a wheel that's the same, and a dish that's the same, and the same size space, and the same temperature, because think about it, if the temperature's different, the hamsters are going to behave differently, and the same amount of sunlight, because hamsters are nocturnal, so at night they'd be more active than during the day, so each cage needs to get exactly the same amount of light. I'd need to give them the same amount of food in their food bowl, even though I was looking at 3 different types of food. This should be the only thing that is different from one group to the next. Okay? And that's why I call them groups, because each cage then would represent one test group. So now I have 3 different test groups. More is better, 3 is good. I have a clearly measurable thing. How could I measure this? Well, I could put a little odometer on the wheel in each cage, and I could measure how often the hamster runs in the wheel. Or I could get a little Fitbit bracelet and put it on the back of each of my hamsters and then chart their activity levels based off the Fitbit. Technology today is wonderful in terms of what you can actually do with a hamster, or anything else for that matter. Now, I have an experiment set up. It has one variable being tested. That's the food. Everything else is completely controlled and the same. Those are my experimental controls. It has Multiple test groups. There's 3 different groups. It's clearly measurable. I can record data and write it down. The only problem is I only have 1 test subject in each group. I have 1 hamster in each group. Why is that a problem? Well, let's say my hamster here in group number 1 has a sort of a hormone problem, and no matter what I feed it, it's going to grow to a gargantuan size and it's going to turn gray. Well, I might assume that that food type just makes hamsters grow gigantic and turn gray. That's not a valid assumption because I'm only looking at 1 test subject per group. So how could I fix this? Well, in each group I should have 7, 8, 10, or 100 test subjects. I'd have to set those up and not just have 1 test subject in each group. Well, that's what makes a good experiment, but what are the actual parts of the experiment? First, the manipulated variable. That's the one thing that's being tested or changed. So in this experiment, I'm trying to find the effect of different types of food, focus on that word different and effect, different types of food on hamsters. So what I set up to be different, what I manipulate in this experiment, the one thing that's different from one group to the next is the manipulated variable. Second, the data is also called the responding variable. So this is what I'm measuring or recording as my data that's going to answer my question. So in this case, it's the activity level of the hamsters. And third is the control group. So this is a special group that's set up that does not contain any of the manipulated variable. Or maybe it's set up as normal, because sometimes you can't eliminate the manipulated variable. The whole point of a control group is so you have something to compare to and to check your materials. So in this test here, I don't have a control group set up yet, because I'm just testing 3 different things. I would need something to compare and say, well, what makes this better than others? I can't give the hamsters no food, because it just won't grow. They'll die. That won't give me any data. So instead, I would set up what's normal. I would set up a control group and give them normal hamster food from whatever environment they normally eat in. That would be a good one. So for instance, if I'm testing the effect of temperature on something, you can't eliminate temperature entirely. That's impossible. So you'd set up whatever the normal temperature range is for that organism, or the normal temperature, sometimes room temperature. Okay, so last thing are some important terms. We've talked about hypothesis. Hypothesis is an educated guess made by one person that's then going to be tested. A scientific theory is kind of the next step in size. It's an explanation of phenomenon. It explains what's going on around us based on large amounts of data. And several different hypotheses are included in that, tested by many scientists. Examples. The heliocentric theory is the theory that the Earth revolves around the sun. Cell theory is the theory that all living things are made up of cells. All these things are really generally accepted as true, and one that we're going to study is the theory of evolution. If new data comes about that could alter or tweak the theory, it can be altered and changed. Next, you have a scientific law, such as Newton's laws of force and Newton's laws of gravity, the laws of thermodynamics, and the conservation of matter and energy. The law of gravity, for instance. This is based on huge amounts of data. So every time anybody has ever dropped thing in all of human history, it's fallen to Earth. It's because the law of gravity is a statement about how the universe works. And it's always happens exactly the same. It's the closest thing you can think of to a scientific fact. Lastly, you've got an inference. Inference is kind of like a conclusion based on whatever data you're looking at. So if you're given a set of data, what can you infer from that data? Well, what logical conclusion can you come to? That's what we're looking at. And last bit of this, often we use the term theory as a way of saying, like, I have a theory about why that's happening. Often really what we mean is a hypothesis. I have a hypothesis about why this is happening. When we say theory in science, it's much more of what you see here.